Alright, in section 7.6 we're introduced to circles and some notation around circles, some vocabulary, etc. And so what I wanted to do is highlight here some of the parts and pieces of this circle. We have a circle with a center at O. On the circle are points A, B, C, and D. And we're going to talk about the measures of the angles at the center. A measure of angle AOB is 60. The measure of angle BOC is 55, and the measure of angle COD is 100 degrees. All right? What we're going to try to do in this section is talk about the measure of the arcs. So what is the measure of the arc that goes from point A to point B, the measure of the arc from B to C, or from A to C, and then also what is the measure of the arc from A all the way over to D. All right? And the measure of the arc is not the same as the length of that arc, all right? The measure is again measured in degrees, but length is going to be measured in inches or meters or miles, etc. And so we're going to talk just in this quick video about the measures of arcs, the arc addition postulate, and of course the notation that's associated with that. So the first comment that I want to make is any arc that is less than a semicircle is considered a minor arc. A minor arc is less than a semicircle, less than 180 degrees. A major arc is greater than 180 degrees, all right, or bigger than a semicircle, all right? The whole way around the circle is 360 degrees. Halfway around the circle is 180. So a semicircle is 180, all the way around is 360. A minor arc is less than 180 degrees, a major arc is greater than 180 degrees. So in this particular situation, we've got this information that's been given to us, and our task is to make sure that we can find the measures of these arcs, all right? And so if we're going to find the measures of arcs, then what we need to know is this simple fact that the measure of an arc is equal to the measure of its central angle, all right? Or another way to say that is the measure of this central angle is equal to the measure of its intercepted arc. So in this particular case, the measure of arc AB, notice the notation I'm using here, I'm writing capital A and capital B, and I have the little arc above those two letters, kind of like when we had segment AB, we drew a line segment above them. If we're talking about line AB, we had the double arrows. Ray AB, we had an endpoint at A going in the direction of B. But if we're going to find the measure of arc AB, we're going to say it's equal to the measure of the angle at the center, the measure of angle AOB, which in this case is 60 degrees. If I want to find the measure of arc AC, this is still a minor arc, so I'm still just using those two letters A and C. I am going to recognize that it's going to be the same as the measure of this entire central angle, AOC. And so the measure of central angle AOC, we aren't given that information directly, but we remember from the beginning of the year, section 1.4, that the angle addition postulate means if this angle is 60 degrees and this angle is 55 degrees, then the measure of angle AOC is the sum of those parts. So the measure of arc AC will be the measure of angle AOC, which in this case is 60 plus 55, or 115 degrees. Finally, if I want to know the measure of the big arc that goes from A past B all the way over to D, or I could refer to this as the same thing, arc ACD. These are the same two arcs, different names for the same exact thing. It goes from A past C all the way over to D. This whole arc right here, all right, has a measure, as my marker dies here, has a measure that is equal to the sum of these parts. And this is going to be bigger than 180 degrees. It's bigger than a semicircle. And so we need to make sure that we add up all of those pieces. The measure of arc ABD is the same as the measure of arc ACD, because they're really the same arc. It's the same arc, just different names for it. Is going to be the sum of the parts. The measure of arc AB and the measure of arc BC and the measure of arc CD. When we add up all those pieces, we get 215 degrees. Alright? Now you can put the little degree symbol in here, but in this class we understand that we're using degrees, so if you forget to use that or decide not to use that symbol, then I of course know what you are talking about. When we are finding the measures of angles, when we're finding the measures of arc, of any arc, we are going to use the measure of the central angle to talk about how these are the same measures. Alright, if we know the measure of the central angle, then we know the measure of the arc. If we know the measure of the arc, then we know the measure of the central angle. If we know the measure of this whole piece, then we can subtract off part of it to find the measure of the other part. And so we can use arc addition postulate just like we use the angle addition postulate to find the measures of arcs.